Hi there. In the previous videos, we explored basics of mouse attributes, handling different types, and how to define custom attribute types. Building upon what we already learned, in this video we will explore somewhat slightly more advanced concepts of attributes that you might find useful at times. Specifically, we will explore coerce, trigger, clear, predicate, auto-deref, weakref, and lazy build. With that said, let's begin. Alright, let's look at coerce first. This keyword allows us to take one type of value for an attribute and convert it to another type. For example, if I wanted to define my attribute as datetime as instance of a datetime class, which allows us to work with dates in Perl, I wouldn't be able to accept another type. What if I wanted to accept strings as well to convert to datetime objects? Now let's see an example. The first thing, let's install the datetime module. So if we go to the terminal and run cpan datetime, it's going to take a minute or two for you to install, but I already have it installed. Once it's done, let's jump back to the editor. Now if we go to our test script, I'm going to say that I want to set my attribute to a string, which is going to be, let's say, year 1991, 12 December, and let's save that. If we go back to the human class, we can say that I want this attribute to be of type of datetime. So this is the module that we just installed, right? So we can add it, let's say, underneath the use mouse, so datetime. If I save this up, and if I run the script, oops, it's going to be Perl, testlib, is going to complain because the attribute test does not pass the validation of datetime, which is a class name, value 1991, 12th of December. However, if I go back to the test script, and let's say I wanted to use the datetime there as well, so datetime, and let's set the test value to datetime now, which is basically initializing a new instance of a datetime class containing all the time values of now, then this should pass. So if I rerun the script, and that looks good. So we are dumping out the test attribute. Now let's go back to the previous example, and let's set it back to 12th of December. Okay, let's save this. If I rerun, just make sure it's failing. Okay, so it's still failing. Now going back to the coerce keyword, so you can say coerce equals 1, and if we rerun our script, nothing's going to happen because we haven't introduced this transformation layer that allows us to take a string and convert it to a datetime object. So the first thing we want to do, as we saw in the previous videos, we want to introduce a new subtype. So I'm going to say that subtype name is going to be custom date, and I want this subtype to be of type as datetime. After we have done that, let's use our new subtype, and that looks good. The next thing we want to introduce is the coerce keyword, which comes from the mouse utilities. If I type coerce, and I say I want to transform my custom date, and I want to transform it from string, so whenever a string is provided for this type, I want to do a specific logic. And that specific logic can be defined in this via keyword, which accepts a code block. Now what we can do here, considering we are getting a string which contains year, month, day, we can extract these values by introducing 3 variables, which are going to be year, month, and day. Oops, it's going to be day, and we say that we want to split it on a regex where we have a hyphen, comma, the local value, which is going to be provided to the attribute and is kept in the $_ and then we want to initialize a new instance of date time new, and how you can set the year, month, and day is by providing attributes of that class, which are year, so that's going to be our year, and month, which is going to be our month, and day, oops, day equals our day variable. Now what we're doing here, we are initializing a new instance of a datetime class, and we're setting a couple of attributes on that class, which are year, month, and day, that we extracted by splitting the value that we are setting it in the test script by providing year, month, and day. If we go back to the human class, the last thing, we are implicitly returning instance of a datetime. Alright, so this looks good, and if we try to rerun this now, it works. So we can see that we provided a string as an attribute test, and we modified it by splitting it up, creating an instance of datetime through this coerce method, and it's being accepted. Now if you, for example, comment out the coerce and rerun the script, you're going to see that it's still complaining. So that's a key point to remember here. You want to keep that coerce keyword active if you want this conversion to happen. Of course, there can be other issues, for example, where we want our string to be in specific format and so on. But for sake of example, I think this is all right. Okay, so the next thing we're going to look at is the trigger keyword. So what I'm going to do, I'm going to remove all of this code that does the transformation of values. I'm going to set this to, not going to set this actually to anything. I'm going to remove it and the coerce as well. And I'm going to replace that with trigger. So what the trigger allows you to do, it accepts a code ref, and every time the attribute is set, it's going to execute some piece of code. For example, I could say warn, and in there, I'm going to warn that test attribute is being set, exclamation mark. Now, if we go back to our test script, and this is being set to the date, this is still fine. We don't care about that. Okay, this looks good. If we rerun our script, we're going to see that there was a warning printed that the test attribute is being set, and then we printed out the value of the test attribute. And note that this warning, or whatever logic you added, is going to be called every single time you're setting the attribute. So for example, it does not necessarily have to happen at the time of initializing a new instance of a human class, but it can also happen if you're overriding the value. For example, human, and we access the test attribute, and we say that this is now ABCD. And if we save this, rerun the script, oops, looks like this attribute is set to read only, so we want to change that to read and write. I rerun the script. Now we can see that there are two warnings. The first one comes from when we initialized a new instance of the class, and the second warning comes from us overriding the attribute with ABCD. So there can be different scenarios where you would like to call that. It really depends on a use case, but it's good to know that it's there. Now the next keyword we can look at is called clearer. And what this keyword allows us to do, it allows us to specify a method name that we can use to remove a value for an attribute and set it to undefined. For example, I can say clear test. So if I do this, rerun the script, before I rerun, I'm going to remove the overriding of the initial value, save the script, just make sure everything's working as intended. So it should be clearer, not clear. If I rerun it, okay, so that looks good. What we can do now, we can actually clear this attribute after calling the human clear test, and we can try to warn dumper human test attribute again. If I run the script, we're going to see that we printed out the year the first time around. We called the clear test attribute, which removed the value that is currently set, and then we printed out again, which now contains undefined, meaning value is not set. The next keyword we're going to look at is called predicate. It allows you to check if a value exists for an attribute. So we can say predicate has test for installing a method on this class that's going to return if a value for test is set or not. We go back to the test script and I'm going to remove the first part. So let's print out the value first, and then we can say human, oops, so it's going to be uppercase human, and has test. We actually want to warn that as well, so warn dumper, okay, and if we run the script, so we're going to see that a value exists and value is set. You might be thinking, well, why is this really useful to check if a value has been set? Now imagine a scenario, for example, if we have some default value, let's say default would be sub, which is a code ref, and we're going to say that we want to warn, I am setting a value, and then we're going to return 20. So if I save this, go back to the test script, but we don't want to set value here anymore. We initialize a new object, so let's leave that empty. I'm going to do, let's say, if human test warn has value. Okay, save this, run the script. And we see that since we called the test attribute, we're also initializing that attribute through the default behavior. And then we're printing out has a value. So what if we actually wanted to test if this value has been set by the caller? Now we can't really call the test attribute itself because it's going to invoke some logic. So this is where the predicate method is very useful. Oops, and looks like I removed the predicate. So predicate, and let's reinstate it. So has test. If we save that again, and I'm going to set this to has test, and let's see what happens there. It looks like it's still printed out that it's setting a value, and this is because, right, so we haven't defined our attribute lazy for this value not to be automatically initialized to the default value when we create an instance. So if you remember from previous lecture, that's what the lazy keyword is for. So basically, when we create an instance of this class, we don't want to set the default value instantly for this attribute. So lazy only initializes the value once we access that attribute. All right, so if we set the lazy and we try to run the script again, it didn't print anything because the predicate only checks if a value has been set for this attribute by the caller. So now, for example, if we, let's just sanity check if we have the lazy keyword, and if we say test, so this should still run the warning, okay, and that's fine. And if we extend this has value with appending human and has test, save that, rerun the script, we're going to see that yes, it has a value, and we printed out 1. However, if you say warn, dumper human has test before we access the test attribute, we're going to see that it doesn't have a value before we run the if statement, and then we access the attribute, it set the value, and now the predicate returns that yes, there is a value. Now the next one is pretty straightforward, and it's called auto deref. And what auto deref allows us to do, it basically dereferences the attribute automatically, as the name implies, based on the context we're working with. For example, if I set auto deref to true and save that, and let's say that our test is now going to, first of all, let's remove everything what we have here. Now I'm going to say that the test holds an array ref with 2 elements, 1 and 2, so numbers 1 and 2. And if I wanted to say that my list equals human and access that attribute, and let's warn this out, so let's print out what's in the list. So I'm going to print the list, save that, rerun the script. Yes, we also need a attribute constraint, type constraint on that attribute. So let's say that this is a array ref. We save that, rerun it. We're going to see that we have 2 elements in that list, which is 1 and 2. So if we don't set the auto deref, save the class, rerun the script, we're going to see that our list contains 1 element, which is array ref coming from this test attribute. And with the auto dereference, we can take that attribute and assign the values to the list. Or it could be hash ref, the values can be dereferenced to hash, and of course other reference types. Alright, so the next one we're going to look at is called weak ref. Now weak ref is quite interesting. To understand the weak ref, you must understand the references. References are really powerful because it allows you to work with references in memory instead of with actual data payload. So instead of copying by value, which can be maybe hundreds of lines of text, you can work with a reference. So you just pass the reference in memory, and that's very quick. However, there can be situations when 2 references can point to itself, creating a reference cycle, and they cannot release each other's memory. It's a little bit confusing concept, but let's see an example. So let's do this. I'm going to remove the datetime because we're not going to need this anymore, and I'm going to create 2 classes. First of all, I'm going to create human1, so new human. We don't care about setting the attribute. I'm also going to create another human class, which is going to be human2. Now we have 2 instances of human class. Now let's check what we have in a test. I'm going to comment out the weak ref for now and go back to the test script. Right, so let's do this. We're going to say that human1 test attribute is going to point to human2. And we're going to say that human2 instance test attribute is going to point to human1. So that might seem that's already asking for trouble. And if we run the script now and let's see what happens, we're going to see nothing at the current time. Now, how can we actually see that there's a circular reference going on here? Now, for that, we can use a module which is called Devel cycle. If you go to the console, you can write cpnm devel cycle, install that. Again, I already have this installed, but it might take a minute or 2 for you. And from there, let's use that. And we're going to say use devel cycle. And this module gives us a method which is called find cycle. And that method is already automatically exported. So if I call find underscore cycle and I give it our human1 instance and rerun the script, oops, is going to be the test script. Now what we can see here, that the find cycle found one cycle. So our human A is pointing to human B, and the human B is pointing to human A. In some cases, this can be completely fine, but the more circular reference you have, the more potential memory leaks there are going to be. So you want to deal with these circular references. So the way how you deal with them is if we go back to the human class and reintroduce the vgraph and save that, rerun our script. And here we go. There are no more circular references. So what happens there, it basically weakens the reference for that attribute to what it's pointing to. Now the question, of course, is how you can figure out that there's a reference cycle. Well, most of the time, there isn't an obvious answer. You're probably going to see that your script might be using too much memory, and then you go debugging, and then you use this module that we just introduced, and so on and so on. It wouldn't be sane to try to print out every single reference and just assure there are no cycles. But if you ever see issues with memory, and you think your script might be consuming too much of it, then know that you can use this Devel cycle to find potential issues with your references. Now the last keyword is called lazy build, and you set it by doing lazy underscore build equals 1. Now the lazy build actually does a couple of things for us automatically. It sets the attribute to lazy 1, so the attribute's value is not being automatically initialized from the default or builder methods. It also has the clearer method, as we saw before, and it also has the predicate method that we looked at before as well. Now we're not going to test all the methods here, but let's do two things. So I'm going to say that it's going to have a default value, where I'm not going to really say there's a value here, but I'm going to do warn setting attribute. So that it's also good to know that by default, these methods, which are the clearer and predicate, are installed as clear underscore attribute name. In our case, that would be test. And for the predicate, it would have has test, as we saw before. Well, we added these namings explicitly, but when you're using the lazy build, just know that the clearer is prefixed with clear underscore and then the attribute name. And the predicate is basically the same, with just a has prefix and then the attribute name. So there should be a capital T as well. If we just quickly test that we can call the has attribute name, we go to our test script and let's just remove everything that we did with circular references. Going to rename this to human. We're not going to need this module anymore. And what we can do is we can say warn dumper human and has test for checking if the test attribute has a value. If we run this, oh yes, because we're using lazy build and installs the build method, we cannot have a default value for this. So what we want to do instead, to introduce a new method here for building a value, which is going to be prefixed with build, similar to the predicate and has, and then the attribute name, so test, and I'm just going to copy the warn and put this here, and let's remove the default one. Right, this should work if we run the script. Alright, we can see the value is not set for the test attribute, and if we just copy this line and between it, I am going to say that human say test equals 1, and oops. So first of all, save it, go to the script, rerun it. So I can remove the second line now, so let's add the has test after setting the attribute value. And we can see the first time around, there is no value for the test. We're printing it out. Then we set a value. Now the human instance has a value for the test attribute, and we're getting back 1 for truthy. Now that's it for this video. We explored a bit more advanced concepts of mouse attributes and how you can apply them in practice. I hope you found this video useful, and I'll see you at the next one.